Right now, you're holding a picture in your mind that is completely wrong. If I ask you to imagine the universe, you probably picture a giant ball of stars floating in an endless black ocean. You picture the Big Bang as an explosion, like a grenade going off in a dark room, sending shrapnel flying outwards into the void. This is the single most common misconception in the history of our species. The truth is far stranger. There is no dark room for the universe to expand into. There is no outside to the bubble. The universe is not a ball floating in space. It is the space itself. And if you could travel faster than light to the edge of what we see, you would not hit a wall and you would not fall off a cliff. You will find yourself right back where you started. This is the story of the true shape of reality, a shape that defies human intuition and breaks the rules of geometry. If you're ready to explore the infinite, hit that like button and subscribe. And tell me in the comments, do you believe the universe goes on forever, or does it have a closed loop? Now settle in, relax, and let the journey begin. The human mind is a pattern-seeking machine, and the pattern we love most is the sphere. It is safe, it is enclosed, it is simple. When our ancestors looked up at the night sky, they saw a dome of stars, a celestial bowl overturned on the flat Earth. Even today, when we launch telescopes worth billions of dollars into the vacuum, they return data that reinforces this old illusion. We look out and see galaxies in every direction, equidistant from us, forming a perfect, shimmering globe of light. It feels natural to assume this is the shape of the whole universe. It feels natural to assume that we are at the center and that there is an edge where the stars stop and the true nothingness begins. But this sphere is a lie. It is a prison built by light and time. Imagine you're a sailor floating in the middle of a vast foggy ocean. You look around and you see a perfect circle of water. The horizon is the same distance from you in every direction. Does this mean the ocean is a circle? Does this mean you're at the center of the ocean? Of course not. The circle is just the limit of your vision. If you sail forward, the horizon moves with you. The circle you see is not the shape of the world. It is just the shape of your view. We are that sailor. The sphere of stars we see is not the universe. It is merely the observable universe. It is a bubble of information, defined by how far light has been able to travel since the beginning of time. The edge of this bubble is not a physical wall. It is a horizon of time. Beyond it lie more galaxies, more stars, and more dark chasms that we simply cannot see yet because their light has not had enough time to reach our eyes. The true shape of the universe, the global geometry, is something else entirely. It is the ocean, not the circle, and this ocean might not be what you expect. For centuries we assumed space was a simple stage, a rigid flat box where events happened. But we now know that space is flexible. It is a fabric that can stretch, twist, and bend. It can curve so intensely that it wraps around itself like a cylinder or flare out like a trumpet bell. The most difficult concept to grasp, the one that keeps astronomers awake at night, is the idea of expansion without a container. When we say the universe is expanding, you likely picture a balloon inflating inside a room. The balloon gets bigger, and it takes up more space in the room. But for the universe, there is no room. There is no external void waiting to be filled. When the universe expands, it does not move into anything. It creates more space between the galaxies, stretching the very definition of distance itself. Think of it not like a balloon, but like an infinite sheet of rubber. If you stretch the rubber, two dots drawn on the surface will move apart. They are not moving into a new area. The surface between them is simply generating more of itself. This means the universe can be expanding and infinite at the same time. It does not need an edge to grow. We're about to leave the safety of our visual horizon. We're going to peel back the illusion of the sphere and look at the raw machinery underneath. We will discover that straight lines can intersect, that triangles do not always add up to 180 degrees, and that the darkness between the stars is not empty, but alive with a force that is pushing us apart. The sphere is just the beginning. The true shape of the universe is waiting in the dark. For most of human history, the edge was a place of terror. Maps of the ancient world ended in dragons, waterfalls, and void. The ocean was assumed to be flat, and if you sailed too far, you would drop off into chaos. We conquered that fear when we realized the Earth was round, a closed loop where you could sail west to find the east. But as soon as we solved the problem of the Earth, We projected that same old fear onto the sky. We looked up and asked, where does it stop? If you could build a ship that never ran out of fuel and you flew in a straight line away from Earth for trillions of years, would you eventually hit a wall? Would you find a sign that says the end? Or would you just fly forever into an endless starless dark? This is the oldest anxiety of our species, the fear of the infinite and the fear of the enclosure. We do not like walls, but we are terrified of a room without them. The modern answer is even stranger than the ancient myths. We have discovered that the universe likely has no edge, there is no wall, there is no cliff, but that does not mean it is infinite. Imagine an ant walking on a giant beach ball. The ant can walk forever. It will never hit a wall. It will never fall off an edge. To the ant, its world feels infinite because there is no barrier to stop it. But the ball is not infinite. It is just finite and unbounded. This is the leading theory for the shape of our reality. We might be living in a hypersphere, a three-dimensional version of that beach ball surface. If this is true, space itself curves back on itself. A spaceship travelling in a straight line for long enough would not find an edge. It would eventually come back to Earth, arriving from the opposite direction. We have traded the dragons and the waterfalls for a hall of mirrors. The edge we see in our telescopes is not a physical boundary, but a horizon of information. It is the point where the light is too old to have reached us yet. We are trapped in a bubble of visibility, floating in a much larger, perhaps infinite ocean that we can never fully map. The true universe continues past our vision, indifferent to our limits, and somewhere out there, beyond the reach of our strongest lenses, the geometry of space might be twisting in ways our minds are not built to comprehend. To understand this, we first have to understand the prison we are in. We have to look at the light itself. We live in a bubble. It is not a bubble of soap, but a bubble of time. When you look at your hand, you are seeing it as it was a tiny fraction of a nanosecond ago. When you look at the moon, you see it as it was 1.3 seconds ago. When you look at the sun, you see it as it was 8 minutes ago. Light is fast, 300,000 kilometers per second, but it is not instant. This simple fact creates the most profound prison in existence, the observable universe. Imagine you're standing in a field at night during a thunderstorm. You are blindfolded. You can only know about the storm when the thunder reaches your ears. If a lightning bolt strikes 10 miles away, you will not know about it for nearly 50 seconds. If the storm just started 5 seconds ago, you are completely deaf to anything that happened more than a mile away. You are trapped in a hearing bubble defined by the speed of sound. The universe works the exact same way, but with light. The universe is about 13.8 billion years old. This means we can only see things whose light has had enough time to travel to us in those 13.8 billion years. If a galaxy is so far away that its light takes 14 billion years to reach us, it is effectively invisible. It is outside our bubble. It might as well not exist. This bubble creates a powerful illusion. Because we can see the same distance in every direction, it looks like we're at the center of the cosmos. But this is just a trick of perspective. Every point in the universe has its own bubble. An alien living in the Andromeda Galaxy has a different observable universe than we do. They can see things we cannot, and we can see things they cannot. But here is the truly disturbing part. The true universe, the universe with a capital U, is likely hundreds of times larger than our bubble. Some theories suggest it might be infinite. This means that the vast majority of reality is permanently hidden from us. We are like a lighthouse keeper who thinks the world ends where his beam fades into the dark. What lies in that darkness? Is it just more of the same, more galaxies, more stars, more emptiness? Or does the universe change its rules when no one is watching? Does the geometry of space twist into shapes that would break our minds if we could see them? We are trapped in our prison of light, but we have found a way to feel the walls, and what we found is that the walls are heavy. If you could drain the oceans of Earth, you would see that the seabed is not flat. It is a landscape of deep trenches, towering mountains, and endless plains. The universe is exactly the same, but instead of water, it is filled with the invisible fluid of gravity. We're used to thinking of space as empty. We imagine it as a blank canvas where stars hang like paintings on a wall. But space is not a canvas. It is a fabric. And this fabric is heavy. Every object with mass, every sun, every planet, every speck of dust sits on this fabric like a bowling ball on a trampoline. They create dips, They create valleys. When you fall towards the Earth, you're not really being pulled by a magnet. You're sliding down the slope that the Earth has pressed into the dark. But the visible stars are just the foam on top of the waves. The real ocean is made of something else. For decades, astronomers looked at how fast galaxies were spinning. They realized that the stars were moving too fast. By all rights, they should have been flung out into the void like water flying off a spinning bicycle wheel. There wasn't enough visible gravity to hold them together. It was as if a ghost was holding onto the stars, keeping them in line. This ghost is dark matter. It is 5 times more abundant than the stuff you and I are made of. It does not shine. It does not reflect light. It does not cast a shadow. It is a transparent scaffolding that holds the universe together. Think of the universe as a giant spider web in a pitch-black room. The strands of the web are made of this invisible dark matter. The galaxies, the only parts we can see, are just tiny dewdrops caught on the silk. We see the dew, so we think the dew is the structure. But the dew is just the decoration. The web is the reality. This invisible web has sculpted the shape of the universe since the beginning of time. It pulled the first atoms together to ignite the first stars. It dug the deep gravitational wells where galaxies now sleep. Without this heavy, unseen hand, the universe would be a thin, featureless soup of particles. There would be no clusters, no galaxies, and certainly no us. We're living in a castle built by a ghost, and we're only just beginning to touch the walls. We need to fix the balloon. Earlier I told you not to think of the universe as a balloon inflating in a room. That is because there is no room. But if we are careful, the balloon can still show us something profound about the nature of distance itself. Imagine you take a deflated balloon and draw 2 small dots on it with a marker. Let's call them Milky Way and Andromeda. Now start blowing up the balloon. As the rubber stretches, the dots move apart. But, and this is the key, they are not moving across the rubber, they are just sitting there. The rubber between them is growing. This is exactly what is happening to space. The galaxies are not flying through the universe like rockets. They are relatively still. It is the space between them that is being created moment by moment. This leads to a terrifying realization. If space is constantly being created between us and the distant stars, then the distance to those stars is increasing. If you wait long enough, the space will expand faster than light can travel through it. There are galaxies we can see today that are already unreachable. Even if we left Earth right now in a spaceship traveling at 99% of the speed of light, we would never catch them. The road in front of us is growing faster than our wheels can turn. We are living in a universe that is slowly pulling itself apart, and this stretching does not just move things away, it cools them down. When the universe was young, it was incredibly hot, a blinding fog of plasma. As space stretched, that heat was spread out over a larger and larger area. Today, that primordial fire has cooled into a faint invisible hum of microwaves that fills every inch of the sky. This is the cosmic microwave background. It is the afterglow of the Big Bang, stretched out by billions of years of expansion until it is just a whisper. This whisper is the most important clue we have. By measuring the tiny fluctuations in this ancient light, variations of less than 1 part in 100,000, we can actually measure the geometry of the universe. We can use this fading heat to check if the balloon is round, flat, or shaped like a saddle. And what the heat tells us is shocking. It tells us that the balloon might not be curved at all. So we have a problem. I told you the universe is like a stretching sheet of rubber. I told you that if you draw dots on it, they move apart. This is the classic balloon analogy, and you will find it in almost every textbook on Earth. It is a beautiful, elegant metaphor. It is also dangerously misleading. The balloon analogy fails because it forces you to imagine a curved surface. A balloon is a sphere. If you walk in a straight line on a balloon, you eventually come back to where you started. This implies that the universe is closed, that it wraps around itself like a globe. But when we look at the real universe, when we measure the light from the Big Bang with our most precise instruments, we do not see a globe. We see something that looks suspiciously, confusingly flat. Now, flat in astrophysics does not mean 2D, like a pancake. It means something much more specific and much harder to visualize. It means that parallel lines stay parallel forever. It means that if you shine 2 laser beams into the void, perfectly parallel to each other, they will never meet and never diverge, even if they travel for 1 trillion years. If the universe were a sphere, like the balloon, Those beams would eventually cross just like lines of longitude meet at the North Pole. If the universe were shaped like a saddle, the beams would peel apart, but our measurements show that they stay straight. This suggests that the fabric of space is not curved on a global scale. It is not a ball, it is not a saddle, it is an infinite grid, and if this is true, the balloon analogy is dead. We are not living on the skin of a bubble. We are living on an endless flat plane that extends forever in all directions, an infinite sheet of paper that is somehow, impossibly, getting bigger without curling up. But wait, if space is flat, then gravity shouldn't exist, remember? Gravity is the curvature of space. So how can the universe be flat and curved at the same time? To answer that, we have to weigh the universe itself, and the scale is balanced on a knife's edge. To find the shape of the universe, we have to do a nearly impossible math problem. We have to add up everything in existence. According to Einstein's general relativity, the shape of space is determined by how much stuff is inside it. If there is a lot of mass, a high density, gravity wins. It pulls space together, curving it into a closed sphere. If there is very little mass, the universe cannot hold itself together. It flares outward, curving like a saddle. But there is a third option. There is a specific perfect amount of matter called the critical density. It is the cosmic Goldilocks zone. If the universe has exactly this amount of matter, down to the last atom, then space will be perfectly flat. It will expand forever, but it will never curve. Astronomers have spent decades trying to weigh the cosmos to see if we hit this magic number. They counted the stars, they weighed the gas clouds, they added up the invisible dark matter, and when they finished the calculation, they found something terrifying. We came up short. The visible matter, the stars, the planets, you and me, makes up less than 5% of what is needed to flatten the universe. Even if you add the massive ghost of dark matter, we only get to about 30% of the critical density. By all logical rights, the universe should be open. It should be shaped like a saddle. It should be a wild, runaway geometry. But remember the lasers, remember the parallel lines. We know the universe is flat. The measurements of the ancient light prove it. So we have a contradiction. The universe acts flat, but it doesn't have enough matter to be flat. Something else must be filling the gap. Something invisible. Something that doesn't pull, but pushes. This is the moment we discovered the dark energy that makes up 70% of reality. It is the missing weight on the scale, and it is not just filling the void, it is tearing it open. We have a problem. We know the universe is flat. We know because we measured the ancient light and found that parallel lines stay parallel. But when we weigh the universe, we come up short. There isn't enough matter, dark or otherwise, to keep space flat. The math doesn't add up. This is where the story takes a turn into the impossible. Imagine you are drawing a triangle on the ground. You measure the three angles. In a flat world, they add up to 180 degrees. If you draw that same triangle on a globe, the angles add up to more than 180. If you draw it on a saddle, they add up to less. Astronomers did this exact experiment, but on a cosmic scale. They used the cosmic microwave background, that ancient heat map of the early universe, as the base of the triangle. They used Earth as the top point, and when they measured the angles, the answer was exactly 180 degrees. This confirmed it. The universe is flat. But here is the twist. If the universe is flat, it means the density of the universe must be exactly equal to the critical density. It must be perfectly full. But we already know that matter only fills 30% of the glass. So, where is the other 70%? It was hiding in plain sight. In 1998, two teams of astronomers were watching distant supernovae, exploding stars that act like cosmic light bulbs. They expected to see the expansion of the universe slowing down, pulled back by the gravity of all that dark matter. Instead, they saw the opposite. The supernovae were dimmer than they should have been. They were moving away faster than expected. The universe wasn't slowing down. It was hitting the gas. This discovery revealed the missing 70%. It wasn't matter. It was energy, a mysterious, invisible pressure built into the vacuum of space itself. We call it dark energy. And unlike gravity, which pulls things together, dark energy pushes them apart. So now the equation is balanced. 30% matter plus 70% dark energy equals 100% of the critical density. The universe is flat. But this flatness comes with a terrifying price. It means we're living on an infinite runway that is stretching out beneath our feet, faster and faster, forever. And if you follow that runway to its logical conclusion, you find a future that is cold, dark, and empty. If you stand on a flat floor and walk forever, you will never return to your starting point. You will just keep going deeper and deeper into new territory. This is the implication of a flat universe. It suggests that space is an infinite sheet. This is a terrifying thought. If the universe is truly flat and infinite, then it contains an infinite number of stars. And if there are an infinite number of stars, then every possible arrangement of atoms must happen somewhere. It means that 1 trillion light years away, there is another galaxy exactly like the Milky Way. Inside it, there is another solar system exactly like ours. And on a blue planet orbiting that yellow sun, there is another version of you, reading this exact sentence at this exact moment. In an infinite universe, the impossible becomes inevitable. But there is a catch. A flat universe is only one possibility. It is the result we get when we look at the light. But light can be tricked. Imagine you are playing a video game. You walk to the right edge of the screen, and your character instantly reappears on the left edge. To you, the player, the world looks flat. Parallel lines stay parallel. The geometry is perfect. But the world is not infinite. It is a loop. This is the theory of the 3 torus. It suggests that our universe might be a cosmic donut. We perceive it as flat because the curvature is happening in a dimension we cannot see. If this is true, then the light from distant galaxies might actually be light from our own galaxy, circling the loop and hitting us from behind. We might be looking at a hall of mirrors, mistaking our own reflection for a stranger in the dark. And if we are, then the universe is not an infinite sheet. It is a small, closed room, and we are trapped inside. We have a paradox. Our measurements say the universe is flat, which implies it is an infinite sheet. But our intuition screams that nothing in nature is truly infinite. Nature loves cycles. It loves loops. So, is there a way for the universe to be both flat and finite? Yes. But to understand it, we have to play Pac-Man. In the classic arcade game, the screen is flat. It is a 2-dimensional square. But if you move Pac-Man off the right edge of the screen, he doesn't disappear into a void. He instantly reappears on the left edge. If he goes off the top, he comes up from the bottom. This screen is a torus, a donut shape, disguised as a flat square. The geometry is flat, parallel lines never cross on the screen, but the topology is closed. It has no edge, but it has a limited area. Cosmologists call this the 3 torus model. It suggests that our 3-dimensional universe works exactly like that screen. If you got in a spaceship and flew in a straight line away from Earth, you would not travel forever. You would eventually see a familiar blue planet approaching you from the front. You would have circumnavigated the entire universe without ever turning the steering wheel. This would mean the universe is not a hall of mirrors, but a hall of windows. If we look deep enough into space, past the billions of galaxies, we might see something impossible. We might see the Milky Way as it looked billions of years ago. We might be seeing our own ghostly reflection, staring back at us from the other side of time. Astronomers have actually looked for these ghost circles in the cosmic microwave background, patterns that repeat in the sky like a wallpaper design. So far, we haven't found a perfect match. But the search continues because the alternative, an endless dumb infinity, is somehow more frightening than being trapped in a loop. And if we aren't in a loop, if the universe is open, then we're sliding down the back of a saddle into a dark future that never ends. We have talked about the sphere and the flat sheet, but there is a third shape, one that is harder to love because it is harder to picture. It is the shape of a hyperbolic universe, often called the saddle. Imagine a Pringles potato chip. It curves up in one direction and down in the other. Now imagine that shape extending forever. In this world, the rules of geometry go haywire. If you draw a triangle, the angles add up to less than 180 degrees. If you shine 2 parallel laser beams, they don't stay straight. They peel away from each other, diverging into the dark. This is the open universe model. It happens if there isn't enough matter to hold space together, if gravity is too weak to fight the expansion. For a long time, this was the leading theory. It fit the data. It explained why the universe felt so empty. In an open universe, space is infinite, but it is a lonely infinity. Because space curves away from itself, galaxies are pushed apart faster than in a flat universe. Eventually, every galaxy becomes an island, unable to see or reach its neighbours. We thought we had ruled this out. We thought the flatness measurements killed the saddle theory. But recent data has cracked the door open again. Some studies of the cosmic background radiation suggest there might be a slight hidden curve, a tiny deviation that hints we are living on a saddle so colossal that it looks flat to our tiny eyes. If this is true, we are not on a stable sheet, we are sliding, and the slide leads to a place where parallel lines don't just never meet. They run away from each other in terror. But whether flat or saddle, both models rely on one thing: lines, straight, perfect lines. But what if I told you that in the real universe, a straight line is a lie? To understand the true shape of space, we have to unlearn what Euclid taught us in school. We have to learn to see the curves in the void. We learn in school that parallel lines never meet. It is the most basic rule of geometry, written down by Euclid more than 2,000 years ago. It feels like common sense. If you draw two train tracks, they will stay the same distance apart forever. But in the universe, common sense is often wrong. Einstein taught us that gravity is not a force, but a curvature. Massive objects like stars and black holes bend the space around them. This means that near a massive object, straight lines are not straight at all. They follow the curve of the land. Imagine two ants walking parallel to each other on a crumpled bedsheet. They start off moving in a straight line, but as they walk over the folds and wrinkles, their paths twist. They might crash into each other. They might drift apart. To the ants, they are walking straight, but the ground itself is betraying them. On a local scale, near stars and galaxies, the universe is undoubtedly non-Euclidean. Triangles near a black hole have strange angles. Parallel light beams bend and cross. We see this every time we look at a gravitational lens, where a distant galaxy appears distorted by the gravity of a closer one. The big question, the one that determines our fate, is whether these wrinkles smooth out when we look at the whole bedsheet. Is the universe just locally bumpy but globally flat? Or is the whole sheet curved? For a long time, we thought the sheet was flat, but we ignored something. We ignored the fact that the sheet is being pulled. There is a hand gripping the edges of the universe, stretching it faster than the wrinkles can form. And this hand is not made of matter. It is made of the dark. There is an intruder in the equation. For most of the 20th century, we thought the shape of the universe was a simple battle between two giants, the kinetic energy of the Big Bang pushing outward and the gravity of matter pulling inward. We thought gravity would eventually win, slowing the expansion until the universe either froze in place or crunched back down into a fireball. But in 1998, we found out the game was rigged. The universe isn't just expanding, it is accelerating. It is as if you threw a ball into the air, and instead of slowing down, it shot upward like a rocket. This acceleration requires a source of energy that defies all common sense, a force that grows stronger as the universe gets bigger. This is dark energy. And it is not just a fuel, it is an architect. Dark energy is actively changing the shape of space. It creates a kind of anti-gravity that pushes galaxies apart. But unlike matter, which dilutes as space expands, dark energy stays constant. As the universe grows, there is more vacuum, which means there is more dark energy, which pushes harder, which creates more vacuum. It is a runaway feedback loop. This has a profound effect on the geometry of the cosmos. Dark energy is smoothing out the wrinkles. It is stretching the fabric of space so taut that any curvature caused by matter is being ironed out. It is forcing the universe to be flat, not by a delicate balance, but by brute force. We are living in a universe that is being inflated by a phantom, and this phantom is doing more than just stretching the void. It is dismantling the structures we see. It is tearing apart the cosmic web that connects the stars. For a long time, we assumed that the universe was smooth. We thought that if you zoomed out far enough, the galaxies would be spread out evenly, like butter on bread. We called this the cosmological principle. It was a comforting idea. It meant that no place in the universe was special, and everywhere was basically the same. But when we finally built maps large enough to see the truth, we found that the butter is lumpy. The universe is not a smooth soup. It is a sponge. It is a vast, intricate web of glowing filaments and dark voids. Galaxies are not scattered randomly. They are strung together like pearls on invisible threads of dark matter. They cluster in dense knots where the threads intersect, forming massive superclusters of thousands of galaxies. And between these threads, there is nothing. We have found great voids, cosmic deserts hundreds of millions of light-years wide where almost no galaxies exist. If our Milky Way were in the centre of one of these voids, we wouldn't have known other galaxies existed until the 1960s. We would have thought we were alone in a black box. But here is the kicker: dark energy is killing the sponge. Because dark energy pushes space apart, it fights against the gravity that pulls matter together. It is stretching the voids, making them bigger and emptier. It is thinning the filaments, making it harder for new galaxies to form. We are living in the last era of structure. The cosmic web is being torn apart in slow motion. The universe is becoming less like a sponge and more like a mist, a lonely, diffuse fog where islands of light drift further and further into the dark. And this tearing isn't just happening to the web, it might be happening to the shape of space itself. To understand this, we have to stop thinking about shapes we can see and start thinking about shapes we can only dream of. Imagine you are a ghost. You can walk through walls, you can pass through floors, but there is one thing you cannot do. You cannot leave the house. Every time you walk through the front door, you find yourself walking in through the back door. Every time you float up through the attic, you come up through the basement. This is the essence of topology. We have spent a lot of time asking if the universe is flat or curved, but that is only half the question. Geometry tells us the shape of the floor. Topology tells us how the room connects. You can have a flat floor in a room that loops back on itself. You can have a curved floor in a room that goes on forever. Why does this matter? Because it changes the definition of infinity. If the universe is topologically simple, like an infinite sheet, then there are infinite stars and infinite versions of you. But if the universe is multiply connected, if it loops, then it might be surprisingly small. It might be a cozy, finite box that just looks infinite because light keeps circling around and around. This would solve one of the biggest headaches in physics. If the universe is finite, we don't have to deal with the madness of infinite duplicates. We don't have to explain where an infinite amount of energy came from. We just have to explain one small, self-contained joule. But if we are living in a looped universe, shouldn't we see it? Shouldn't we look up and see the back of our own heads? Astronomers have been hunting for these ghost images for decades, and while they haven't found a perfect mirror yet, they have found hints that the room might be shaped like something you would never guess. Something that looks less like a box and more like a soccer ball. I mentioned the 3 torus, the Pac-Man universe, but let's dig deeper into why this is more than just a fun analogy. In a 3 torus universe, space is a cube where opposite faces are glued together. If you exit the top, you enter the bottom. If you exit the right, you enter the left. If you exit the front, you enter the back. This shape is mathematically perfect. It allows the universe to be flat, Euclidean, without being infinite. It solves the problem of the edge without creating the terrifying problem of endless duplication. It means the universe has a finite volume, a specific amount of space that you can measure, but no boundaries. Imagine you're inside a room lined with mirrors on all 6 walls. You look up and you see an infinite tunnel of U's stretching upward. You look left and you see an infinite line of U's stretching sideways. The room looks infinite, but it isn't. There is only one U. There is only one room. The rest is just an illusion created by the geometry. If we live in a 3 torus, the universe is that room. The billions of galaxies we see might be optical illusions, ghosts of the same few thousand galaxies, seen over and over again at different ages. This theory is elegant, it is simple, but it has a competitor. A shape so complex, so beautiful, and so strange that it took a century of mathematics to even describe it. It is called the Poincaré dodecahedral space, and it turns the universe into a soccer ball. In 2003, a group of French astrophysicists led by Jean-Pierre Luminet proposed an idea that sounded like madness. They looked at the data from the cosmic microwave background, the oldest light in the universe, and noticed something missing. The light showed ripples of all different sizes like waves on a pond, but the biggest waves were gone. It was as if you were playing a drum, but the deep bass notes were silent. This shouldn't happen in an infinite universe. Infinite space should be able to vibrate at any frequency, no matter how low. The only way to kill the bass notes is to make the drum smaller. Luminet calculated that the universe might be finite, and it might be shaped like a dodecahedron, a 12-sided shape made of pentagons. This is the Poincaré dodecahedral space. Imagine you're inside a giant soccer ball. If you fly out through one of the pentagons, you don't leave the ball. You instantly re-enter through the matching pentagon on the opposite side, but with a twist. You're rotated 36 degrees. This shape is incredibly efficient. It traps light in a complex repeating pattern that would explain exactly why the big waves are missing. It fits the data better than the infinite flat sheet. It fits the data better than the simple donut. If this theory is right, the universe is a hall of mirrors with a twist. And if we look hard enough at the sky, we should be able to see circles of matching patterns, places where the light has looped around the soccer ball and crossed its own path. We haven't found these circles in the sky yet, but the search isn't over. We might just need better glasses, or perhaps we are looking for the wrong shape entirely. Maybe the universe isn't a ball, maybe it's a horn. We have looked at the flat sheet, the saddle, the donut, and the soccer ball, but there is one shape that is perhaps the most unsettling of all, because it suggests that the universe is finite in one direction and infinite in the other. It is called the Picard horn. Imagine a trumpet that gets narrower and narrower as you go down the neck. But unlike a normal trumpet, this neck never ends. It stretches out infinitely, getting thinner and thinner but never actually closing off. The wide end of the trumpet, the bell, flares out, but it eventually wraps around itself, creating a finite volume. If we lived in the neck of this horn, the universe would look very strange. In one direction, towards the bell, we would see distant galaxies as normal. But in the other direction, down the neck, the universe would feel claustrophobic. The walls of the universe would be closer together. If you looked that way, you wouldn't see infinite stars. You would see the same few stars repeating over and over again in a dizzying infinite tunnel of mirrors. This shape is a valid solution to Einstein's equations. It is mathematically sound. And some cosmologists argue it could explain why the universe looks so different depending on which way we look. We often assume the universe is isotropic, the same in all directions. But recent maps suggest this might be a lie. We see strange alignments of quasars. We see a cold spot in the cosmic background radiation that shouldn't be there. These anomalies might be the walls of the horn pressing in on us, squeezing the geometry of space into a shape we're too small to see. We are like bacteria living on the surface of a cymbal, unaware that the metal is vibrating in a pattern far larger than our entire world. And just when we think we have a handle on the 3D shape, we have to ask the question that changes everything. Why stop at 3 dimensions? We have been talking about space as if it only has 3 directions: up, down, left, right, forward, backward. We assume this is the whole story because that is all we can feel. But what if space has more directions that we are blind to? Think of a tightrope walker balancing on a high wire. To him, the wire is a one-dimensional line. He can only move forward or backward, but to an ant crawling on that same wire, the world is 2-dimensional. The ant can crawl around the wire, exploring a direction, a curvature, that the walker cannot even perceive. We might be the tightrope walker. String theory, one of the leading candidates for a theory of everything, suggests that the universe must have at least 10 dimensions to work. If this is true, then where are the other 6? The answer is that they are compactified. They are curled up into tiny microscopic knots at every single point in space. Imagine that every point in the air in front of you is not really a point, but a tiny 6-dimensional ball of yarn, far too small for your eyes or even our best microscopes to see. This sounds like pure fantasy, but it would explain why gravity is so weak. Gravity might be leaking into these extra dimensions, diluting its strength like water spreading into a sponge. It would also change the shape of the universe in ways we can barely comprehend. The flat sheet we see might just be a single page in a cosmic book, floating next to other pages we can never touch. This leads us to the brain world theory, the idea that our entire 3D universe is just a membrane floating in a much larger, higher dimensional space called the bulk. And if there is a bulk, there might be other brains, and if there are other brains, they might be getting closer. We are used to thinking of the universe as everything that exists, but what if our universe is just a single sheet of paper floating in a library? This is the brain world theory. It suggests that our entire 3D reality is a membrane, or brain, floating in a higher dimensional space called the bulk. Imagine you are a stick figure drawn on a piece of paper. You can move left, right, up, and down. You're a 2D creature. You have no concept of forward or backward because those directions point off the paper. You are trapped on your 2D brain. Now imagine that a 3D human walks past your paper. You cannot see them. But if they step on your paper, you would feel a sudden, inexplicable force. You would see a footprint appear out of nowhere. This is what gravity might be. Physicists have long been puzzled by how weak gravity is. A tiny magnet can lift a paperclip against the entire gravitational pull of the Earth. Why is gravity so feeble compared to magnetism? The brain-world answer is that gravity is the only force that can leave the paper. It leaks out into the bulk. It spreads into the extra dimensions, diluting its strength. We are stuck on the brain. Our atoms, our light, our bodies are glued to this 3D surface, but gravity is free. It is a traveller. And if gravity can travel between brains, it raises a terrifying possibility. What if there is another sheet of paper right next to ours? A parallel universe could be hovering just a millimetre away from your face, displaced in a fourth dimension you cannot see. You would never be able to touch it. You would never be able to see it, but you might be able to feel it. The gravity of a shadow galaxy on the other brain could pull on our stars, creating the illusion of dark matter. And if these sheets are floating in the bulk, they are not necessarily stationary. Sometimes they might drift. Sometimes they might touch. And when two universes touch, the result is not a handshake, it is a big bang. The most disturbing idea in modern physics doesn't come from the depths of space, but from the surface of a black hole. When you throw a book into a black hole, the information in that book, the words, the ink, the structure of the pages, seems to disappear. But the laws of quantum mechanics say that information cannot be destroyed. So where does it go? The answer, proposed by Stephen Hawking and others, is that the information is plastered onto the event horizon, the spherical surface of the black hole. It is stored there like a 2D sticker on a 3D ball. The book is gone, but its image remains on the surface. This led to a radical thought. If a 3D black hole can be fully described by its 2D surface, what if the whole universe works the same way? This is the holographic principle. It suggests that our entire three-dimensional reality, the stars, the planets, your body, the room you're sitting in, is actually a projection from a distant two-dimensional surface. We are like characters in a movie. We look 3D, we feel 3D, but we are really just light projected from a flat film. If this is true, then the shape of the universe is an illusion. The real universe is a flat shell of data, encoded in zeros and ones at the edge of existence, and we are just the ghosts emerging from the code. This theory sounds like science fiction, but it solves major mathematical problems. It explains why gravity is weird. It explains the nature of information. But it also forces us to ask a question that makes astronomers uncomfortable. If reality is pixelated like a screen, can we see the pixels? If the universe is a hologram, a projection of data from a 2D surface, then it must have a limit. A screen can only hold so many pixels. A book can only hold so many letters. This leads to a mind-bending prediction. Space is not smooth. If you zoom in on a photo on your computer screen, eventually the image breaks down into squares of colour. The illusion of a smooth curve disappears and you see the jagged edge of the grid. Many physicists now believe the universe works the same way. If we could zoom in far enough, past the atom, past the proton, past the quark, we might hit the Planck scale. This is the smallest possible unit of distance. It is the pixel of reality. At this scale, the smooth geometry of Einstein's universe shatters. Space becomes a quantum foam. It bubbles and boils, up becomes down, past becomes future. Holes open and close in the fabric of space-time faster than light can cross them. This pixelation would explain why our two biggest theories, general relativity, the smooth geometry of gravity, and quantum mechanics, the choppy math of particles, hate each other. They are trying to describe two different worlds, the smooth photo and the jagged pixels. Astronomers are currently looking for evidence of this graininess. They are watching light from the most distant explosions in the universe, hoping to see if the light waves have been blurred by travelling through billions of years of quantum foam. If they find this blur, it will prove that space is not a continuous sheet. It is a digital grid, and we are living in a simulation of geometry. But if our universe is a discrete bubble of pixels, it begs the question, what lies outside the bubble? And are there other bubbles out there? If our universe is a bubble of quantum foam, it is probably not the only one. For decades, the multiverse was a fringe idea, a place where comic book writers went to fix plot holes, not where serious physicists went to do math. But today, the multiverse is not just a possibility, it is a necessity of our best theories. The culprit is eternal inflation. We believe that just after the Big Bang, the universe expanded at an insane, impossible speed, stretching from the size of a proton to the size of a grape in a fraction of a second. But here is the catch. This expansion doesn't stop everywhere at once. Imagine a giant block of rising bread dough. This dough represents the rapidly expanding space of the multiverse. As it rises, tiny bubbles of air get trapped inside. In these bubbles, the rising stops. The energy of the expansion dumps into heat and matter, creating a stable pocket of space. We are inside one of those bubbles, but the dough, the inflationary field, keeps rising around us, forever. It keeps creating more bubbles, infinite bubbles. Some are small, some are huge, some have different laws of physics. In one bubble, gravity might be repulsive. In another, light might be heavy. This turns the cosmos into a block of Swiss cheese. We are living in one hole in the cheese, convinced that our hole is the entire universe. But just beyond the walls of our reality, there are other holes, and sometimes the cheese gets squeezed. Sometimes the bubbles crash into each other. If we are living in a multiverse of bubbling Swiss cheese, what happens when two bubbles touch? It is a violent event. When two expanding universes collide, they don't just merge, they smash against each other with the force of 1 trillion Big Bangs. The collision creates a shock wave that ripples through the fabric of both universes, leaving a permanent scar. Cosmologists call this a cosmic bruise. If our universe was hit by another bubble early in its history, that bruise should still be visible today. It would show up as a perfectly circular ring of distorted temperature in the cosmic microwave background. The radiation inside the ring would be slightly hotter or colder than the radiation outside, marking the point of impact. Astronomers have actually looked for these bruises, and in 2010, a team claimed to have found 4 of them. They found circular patterns in the sky that were statistically unlikely to happen by chance. However, the evidence is controversial. Other teams have argued that the circles are just random noise, like seeing a face in a cloud. But the possibility remains. We might be looking at the first physical evidence that we are not alone. We might be staring at the fender-bender damage from a collision with another reality. But collisions are not the only way universes can interact. There is a quieter, spookier connection that might bind us to other worlds. It is called quantum entanglement, and it suggests that even if we never touch another universe, we might be tethered to it by an invisible thread. If you flip a coin, it lands on heads or tails. In our world, one happens and the other doesn't. But in the quantum world, the coin lands on both. This is the famous concept of superposition. A particle can exist in multiple states at once until it is measured. But when we measure it, we only see one result. The question is, what happened to the other one? According to the many worlds interpretation, the other result didn't vanish. It happened in a separate, branching reality. Every time a quantum event happens, every time a photon hits a leaf, every time an electron jumps in orbit, every time you make a choice, the universe splits. In one branch, the electron jumped. In the other, it didn't. This means there are infinite versions of you, branching off every fraction of a second. There is a version of you that stopped reading this sentence. There is a version of you that never clicked on this video. But here is the most haunting part. These branches might be connected. Quantum entanglement is the phenomenon where two particles remain linked, even across vast distances. If you spin one particle, the other instantly spins in the opposite direction, faster than the speed of light. This spooky action at a distance baffled Einstein. But if the many worlds theory is true, entanglement might be the thread that binds the multiverse together. Some physicists speculate that particles in our universe could be entangled with particles in a shadow universe. We might be quantumly tethered to our own twins. The choices they make could subtly influence the probability of the choices we make. We are not just isolated individuals, we are a chorus of selves, singing in harmony across 1 billion different timelines. We have talked about how the universe began, how it is shaped, and how it might be connected to others. But there is one final question we have to face. How does it end? If dark energy continues to push the universe apart, the future is bleak. But just how bleak depends on exactly how strong this energy is. If the strength of dark energy stays constant, the universe will end in a big freeze. Galaxies will drift apart, stars will burn out. The universe will become a cold, dark graveyard where nothing ever happens again. But some data suggests that dark energy might be getting stronger over time. This is called phantom energy, and if this is real, the universe won't just freeze, it will be torn to shreds. In a big rip scenario, the expansion of space becomes so violent that it overcomes every other force in nature. First, it will tear the galaxies apart. Then, it will tear the solar systems apart. Earth will be ripped away from the sun. Then, the expansion will become strong enough to overcome the electromagnetic force tearing molecules apart. Finally, in the last fraction of a second, it will rip atoms themselves into subatomic confetti. The fabric of space itself will be shredded. Time will lose its meaning. The geometry we have spent this whole journey exploring, the sphere, the sheet, the saddle, will cease to exist. This is the most violent end imaginable. But it is not the only one. There is a chance that the universe has a restart button. We have spoken about the big freeze and the big rip, endings where the story stops. But nature rarely stops. Nature loves cycles. Day turns to night. Winter turns to spring. Life turns to death, which feeds new life. Why should the universe be any different? There is a theory that suggests the Big Bang was not the beginning, but a bounce. This is the cyclic universe model. Imagine the universe as a giant lung. It breathes in, expanding for billions of years. Galaxies form, stars burn, life evolves. But eventually the expansion slows down. Gravity, or perhaps a change in the dark energy field, takes over. The universe begins to breathe out. Space contracts. Galaxies rush toward each other. The sky grows bright with the light of 1 trillion merging stars. The universe shrinks smaller and smaller, hotter and hotter, until it crunches down into a single microscopic point. And then it bounces. The big crunch becomes the seed for a new Big Bang. A new universe is born from the ashes of the old one. New laws of physics might crystallize. New stars might burn. If this is true, then we are not living in the first universe. We might be living in the 50th or the billionth. Our history, our entire reality, might be just one beat in an eternal cosmic heart. But there is a problem with this beautiful cycle. It requires the universe to stop expanding. And right now, as we look at the dark energy tearing our sky apart, it looks like the lung is stuck on inhale. The universe is breathing in, and it refuses to breathe out. This leads to a future not of fire, but of isolation. A future where we are trapped in a bubble of light that is getting smaller every day. We have travelled from the illusion of the sphere to the terrors of the big rip. We have looked at loops, horns, and holes in the Swiss cheese. But there is one final shape we have to discuss. It is the shape of our own ignorance. The most humbling fact in cosmology is that we may never know the true shape of the universe. Because the universe is expanding, and because that expansion is accelerating, there is a limit to what we can ever see. We call it the cosmological horizon. It is a wall of time. Anything beyond it is moving away from us faster than the speed of light. No signal, no light, no information can ever reach us from the other side. If the universe is a horn, or a donut, or a soccer ball, the evidence might be hiding just past this horizon. We might be living in a universe that is clearly, obviously looped, but the loop is too big for us to see. We are like an ant standing on a rug that is being pulled out from under its feet. We can only see the few inches of fabric around us, while the rest of the pattern stretches away into the dark. This means that the global geometry, the true shape of everything, might be permanently unknowable. We're trapped in our local patch, forced to guess at the design of the whole castle based on the few bricks we can touch. But even if we are blind to the whole, we can still see the beauty of the parts. And perhaps the universe isn't made of shapes at all. Perhaps it is made of something much purer. Deep down, physicists suspect that geometry itself might be a lie. We have spent this entire journey talking about shapes, spheres, donuts, horns, and saddles. We have visualized space as a fabric that stretches and bends. But these are just metaphors. They are stories we tell our monkey brains to make sense of the data. The universe does not speak in shapes, it speaks in numbers. Recent breakthroughs in a field called amplituhedron theory suggest that space and time are not fundamental. They are not the bottom layer of reality. Instead, they are an emergent property, a hallucination created by a deeper, purely mathematical structure. Imagine a video game again. On the screen you see a 3D world with hills, valleys and time. But if you crack open the computer, you don't find tiny hills inside. You find code. You find sequences of numbers that have no shape, no size and no time. The world on the screen is just the way that code looks when it's processed. The universe might be the same. The amplituhedron is a geometric object that exists outside of space and time. It is a jewel of pure math. When you shine a light through this jewel, the pattern it casts on the wall is physics. The pattern is the particles, the forces, the gravity, and the time that we experience. If this is true, then asking, what is the shape of the universe? Is like asking, what is the shape of the number 7? It is a category error. The universe isn't a place. It is a thought. It is a mathematical necessity that simply is. And this leads us to the final quiet realization about where we actually live. We have reached the end of our map. We have travelled from the comforting illusion of the sphere to the flat, infinite sheets, through the halls of the three torus and the twisted mirrors of the Poincaré dodecahedron. We have seen how the universe might be a bubble in a block of cosmic Swiss cheese, or a hologram projected from the edge of a black hole. But the most profound shape of all isn't one we can draw. When we look out into the dark, we are not just measuring distances or counting galaxies. We are looking for a reflection. We are asking the universe to tell us what we are. Are we the centre of a finite, cosy box? Are we a random accident on an infinite, indifferent plane? Are we one of a billion versions of ourselves playing out every possible life in a multiverse of madness? The answer the universe gives us is silence, but it is a silence that speaks. It tells us that we are small, yes, but it also tells us that we are significant. We are the part of the universe that has woken up. We are the hydrogen atoms that, given 13.8 billion years, learned to ask where they came from. We are the way the cosmos knows itself. Perhaps the true shape of the universe is not a circle, or a saddle, or a horn. Perhaps it is a question mark. It is a puzzle that invites us to keep looking, to keep measuring, to keep wondering. The horizon will always be there, just out of reach, teasing us with the promise of what lies beyond. And maybe that is the point. The universe is not a thing to be solved. It is a home to be explored. So tonight, when you look up at the stars, don't just see points of light. See the curve of the horn, see the shadow of the brain, see the ghost of the Big Bang, and remember, you're not just in the universe. You are the universe looking back at itself, trying to understand the shape of its own soul. If the universe is a shape, then time is the road we travel through it. But the road has a strange rule. You can only walk in one direction. You can walk north, then turn around and walk south. You can drive east, then drive west. But you cannot go back to yesterday. This is the arrow of time, and it is one of the biggest mysteries in physics. According to the fundamental laws of particles, the math that governs atoms and electrons, time is reversible. If you filmed a pool game and played it backward, the physics would still work perfectly. The balls would bounce, transfer energy, and obey Newton's laws just fine. But in the real world, you never see a shattered egg unbreak itself. You never see smoke swirl back into a cigarette. This one-way street is enforced by entropy. Entropy is a measure of disorder. The universe loves mess. It is much easier to be messy than to be tidy. There is only one way to arrange a deck of cards in perfect order, but there are billions of ways to mix them up. Because there are so many more messy states than tidy ones, the universe naturally slides toward chaos. This slide is what we feel as time. We remember the past because the past was orderly. We don't know the future because the future is high entropy chaos. We are surfing on a wave of disorder that started at the Big Bang, the moment of supreme order, and will end only when everything is evenly spread out, cold, and dead. But what if the river freezes? We feel time flowing like a river. We feel the now moving forward, eating up the future and leaving the past behind. But Einstein suggested that this feeling is a hallucination. In his theory of relativity, Einstein described space and time as a single fabric, space-time. If you look at the universe from the outside, if there is an outside, you wouldn't see a movie playing frame by frame. You would see the whole reel at once. This is the block universe theory. Imagine a loaf of bread. One slice is the dinosaurs. The next slice is the Roman Empire. The middle slice is you, reading this right now. The last slice is the death of the sun. In the block universe, the whole loaf exists at the same time. The dinosaurs aren't gone, they're just down the street. The future isn't unwritten, it is just waiting for you to walk into it. This implies that the distinction between past, present and future is an illusion created by our consciousness. We are like a spotlight moving across a dark room, illuminating one slice of the block at a time. But the room itself, the block, is static. It is frozen. If this is true, then free will is the biggest ghost story of all. You have already made every choice you will ever make. The script is written. You're just learning your lines. But there is one thing that might be able to melt the ice. There is a hole in the block universe, and it is shaped like an eye. In the strange world of quantum mechanics, reality doesn't seem to decide what it is until someone looks at it. We talked about particles being in two places at once, or cats being dead and alive. But the moment you measure them, the moment an observer enters the room, the universe snaps into a single reality. This is the observer effect, and it suggests that consciousness isn't just watching the show, it is directing it. Some physicists argue that the universe requires an observer to exist. Without eyes to see it, without a mind to record it, the cosmos is just a haze of probabilities, a fuzzy, undefined dream. It is the act of looking that solidifies the chaos into stars, planets, and atoms. This leads to a dizzying thought. We spent billions of years evolving from the dust of dead stars. We are the universe's way of building eyes. But maybe the universe needs us to build those eyes so it can become real. Maybe we are the pin that holds the map to the wall. But if we are the observers, who is observing us? If the universe is pixelated, as we saw with the Planck scale, and if it follows strict mathematical rules, as we saw with the amplitahedron, and if it only renders what is being looked at, the observer effect, then it starts to look suspiciously like something we humans have built. It looks like a video game. This is the simulation hypothesis. It suggests that our entire reality, the galaxies, the history, the feelings of love and pain, is a computer program running on a machine in a higher dimension. Think about it. In a video game, the computer doesn't render the whole world at once. It only renders what the player is looking at to save processing power. Doesn't that sound exactly like the observer effect? In a game, there is a limit to how fast you can move, the speed of light, and a limit to how small things can be, pixels, Planck scale. We might be artificial intelligence living in a box. The Big Bang was just the moment the simulation was booted up. The dark energy tearing the universe apart might be a bug in the code, or perhaps the hard drive running out of space. And if we are in a simulation, the creators might be watching, or maybe they got bored and walked away. Which would explain why, when we shout into the dark, no one answers. We have built telescopes that can see back to the beginning of time. We have mapped billions of galaxies, each with billions of stars. We know that the ingredients for life are everywhere, and yet the sky is quiet. This is the Fermi paradox. Where is everyone? If the universe is infinite, or even just very big, aliens should be everywhere. They should have colonized the galaxy by now. We should see their megastructures blocking the light of stars. We should hear their radio waves humming in the void, but we see nothing, just dead rock and silent gas. There are terrifying answers to this silence. Maybe life is incredibly rare, and we are the first to wake up. Maybe civilizations always destroy themselves with nuclear fire or biological terror before they can leave their home planets. Or maybe there is a great filter, a challenge so hard that no species has ever passed it. Maybe it lies in our past, the jump from single cells to complex animals, and we are the lucky winners. Or maybe it lies in our future. Maybe there is a trap waiting for every advanced civilization, a test that no one survives. Or perhaps the answer is simpler and sadder. Maybe the universe is just too big. Maybe we are like two people stranded on different islands in a limitless ocean, waving flares that are too small to be seen, screaming into a wind that drowns us out. We are not alone, but we are effectively alone, trapped in our own little bubble of space-time forever out of reach. But even in the silence, we keep listening, because the only thing scarier than finding out we are not alone is finding out that we are. We assume that the laws of physics are set in stone. We assume that an electron is an electron and that gravity is gravity. But what if the very foundation of our universe is just a temporary arrangement? This is the theory of vacuum decay. Imagine a ball sitting in a valley. It is stable. If you nudge it, it rolls back down. We believe the universe is currently sitting in a valley like this, a stable state called the Higgs field, which gives particles their mass. But calculations suggest that our valley might not be the deepest one. There might be a deeper, true valley further down the hill. We are just stuck on a ledge, a false vacuum. If this is true, then at any moment a tiny bubble of the true vacuum could appear anywhere in the cosmos. Maybe it happens because of a violent quantum fluctuation. Maybe it happens inside a black hole. Once this bubble forms, it will expand at the speed of light. Inside the bubble, the laws of physics will be completely rewritten. Atoms might not hold together, chemistry might be impossible. Because it moves at the speed of light, we would never see it coming. One moment, you are reading this sentence. The next moment, the laws of physics that hold your atoms together simply cease to exist. The universe would be reformatted without warning. If the universe lasts forever, eventually strange things will happen. We talked about entropy, how things tend to get messy. But in an infinite amount of time, even the messiest room will randomly arrange itself into a perfect picture for a split second just by pure chance. This leads to the most disturbing thought experiment in physics, the Boltzmann brain. Physicists have calculated that it is statistically much harder to create a whole universe with billions of galaxies and billions of years of history than it is to create a single functioning brain out of random atoms. In a timeless, chaotic void, particles will randomly bump into each other. Given eternity, they will eventually bump together to form a brain, complete with memories. This brain would think it is a human living on Earth. It would remember a childhood that never happened. It would remember reading an article about cosmology. It would feel the sunlight on its skin. But in reality, it is just a glob of matter floating in deep space, hallucinating its entire existence for a few seconds, before dissolving back into the chaos. The math says these freak observers should be far more common than real biological humans. So how do you know you aren't one of them? How do you know that your entire life isn't just a fever dream that started 5 seconds ago and will end in 5 seconds? We know the universe is expanding. We know galaxies are flying apart. But in our local corner of space, something is fighting the flow. Something is pulling us. Our Milky Way galaxy, along with 100,000 other galaxies, is flowing like a river toward a single point in the sky. We're moving at over 1 million miles per hour toward a region in the Centaurus constellation. We call this gravitational anomaly the Great Attractor. The scary part is that we can't see what it is. It lies directly behind the zone of avoidance, the thick band of dust and stars in our own galaxy that blocks our view of the deeper universe. We are like a ship being dragged by a current toward a waterfall we cannot see because of the fog. Is it a massive supercluster of galaxies? Is it a knot of dark matter? Or is it something else? Whatever it is so massive that it is bending the path of millions of galaxies, dragging us all toward a meeting point billions of years in the future. Black holes are the universe's trapdoors. Things go in, but they never come out. But Einstein's equations are time-symmetric. If you run the math of a black hole backward, you get something impossible. You get a white hole. A white hole is a region of space that nothing can enter. It is the opposite of a black hole. Instead of sucking matter in, it spews matter and light out. It is a cosmic gusher, a fountain of energy that cannot be shut off. For a long time, these were thought to be just mathematical curiosities. But some new theories suggest they might be the answer to how black holes die. When a black hole shrinks and evaporates over trillions of years, it might not just vanish. It might undergo a quantum bounce, flipping inside out to become a white hole. All the information and matter it swallowed over its lifetime would be instantly ejected back into the universe. This leads to a beautiful idea about the Big Bang itself. What if the Big Bang was just a massive white hole? What if our universe is the exhale of a dead universe that collapsed into a black hole billions of years ago? We like to think we are nothing special. The Copernican principle states that Earth is just a random rock, orbiting a random star in a random galaxy. We are not the centre of anything. But when we look at the cosmic microwave background, the afterglow of the Big Bang, We see something that makes astronomers sweat. We see a pattern called the axis of evil. The hot and cold spots in the ancient radiation should be random, but they aren't. They seem to be aligned. Specifically, they seem to align with the plane of our own solar system. This shouldn't be possible. The Big Bang happened 13.8 billion years ago. The solar system formed 9 billion years later. There is no reason why the oldest light in the universe should know about the orientation of Earth. Is it a coincidence? Is it a mistake in our telescopes? Or is the universe smaller and stranger than we think? Some physicists argue that this alignment proves we are living in a specific weird topology, maybe a universe shaped like a slab universe, that is thinner in one direction than the others. Or maybe, just maybe, the Copernican principle is wrong. Maybe we are looking in the mirror and the universe is looking back, winking at us from across the abyss. If you were baking a cake, you would need to be precise with your ingredients. Too much flour and it is a brick. Too little sugar and it is bread. But the recipe for the universe is so precise that it makes a soufflé look like a mud pie. Physicists have discovered that the fundamental constants of nature, the numbers that define gravity, electromagnetism, and the nuclear forces, are tuned to an impossible degree. Take the force of gravity. If it were slightly stronger, stars would burn through their fuel in a few years, leaving no time for life to evolve. If it were slightly weaker, stars would never ignite at all. Or consider the ratio of the electron's mass to the proton's mass. If this number were changed by a tiny fraction, atoms couldn't form. There would be no chemistry, no water, no DNA. This is the fine-tuning problem. The probability of these numbers falling into the narrow Goldilocks zone for life by pure chance is effectively zero. It is like throwing a dart from the moon and hitting a specific bullseye on Earth. There are only two explanations. One is that the universe was designed, which pushes physics into theology. The other is the anthropic principle. It suggests that we shouldn't be surprised by these perfect numbers, because if they were any different, we wouldn't be here to measure them. We are the winners of a cosmic lottery who are shocked that we won, forgetting that the billions of losers aren't here to complain. But this implies that there are billions of losers. It implies a multiverse of dead, broken universes where the numbers were wrong. There is one number, however, that is so wrong it keeps physicists awake at night. We talked about the vacuum energy, or the cosmological constant, the energy of empty space that causes the universe to accelerate. Quantum field theory allows us to calculate how strong this energy should be. When we do the math, adding up all the fluctuations of the quantum fields, we get a huge number. But when we look at the actual universe, the energy we see is tiny. The difference between the theoretical prediction and the observed reality is not just a small error. It is off by 120 orders of magnitude. That is a 1 followed by 120 zeros. This is the vacuum catastrophe. It has been called the worst theoretical prediction in the history of science. If the vacuum energy were as strong as the math says it should be, the universe would have ripped itself apart microseconds after the Big Bang. Atoms would never have formed. Space would have expanded so fast that light couldn't travel an inch. So, why is the real number so small? Why is it almost zero, but not exactly zero? Some theorists believe that something cancelled out the massive energy, leaving just a tiny sliver behind. But that cancellation would have to be precise to 120 decimal places, a miracle of mathematics that we cannot explain. We assume the past causes the future. You drop a glass and then it breaks. But in the quantum world, the arrow of cause and effect might point both ways. In 1978, the physicist John Archibald Wheeler proposed a thought experiment called the delayed choice. It is a variation of the famous double-slit experiment, where a photon acts like a wave if you don't watch it, and a particle if you do. Wheeler asked, what if we wait to decide whether to watch it until after the photon has already passed the slits? Amazingly, actual experiments have confirmed that the photon seems to know what you're going to do in the future. If you decide to measure it at the very last nanosecond, the photon acts as if it had always been a particle. If you decide not to measure it, it acts as if it had always been a wave. It is as if your choice in the present reaches back in time and rewrites the history of the photon. This suggests a terrifying possibility, that the history of the universe is not fixed. We might be creating the past of the cosmos right now simply by observing it. The Big Bang might not be a distant memory that caused us. It might be a retrocausal ripple caused by us. Neutron stars are the densest objects in the universe that aren't black holes. They are city-sized balls of pure nuclear matter crushed by gravity until atoms dissolve. But deep inside their cores, something even stranger might be growing. Standard matter is made of up and down quarks, but at extreme pressures some quarks might mutate into strange quarks. This creates a new substance called strange matter. Strange matter is the most stable substance in the universe. It is so stable that if it touches normal matter, it infects it. It converts the normal protons and neutrons into more strange matter. This means a neutron star might spew out tiny droplets of this stuff, strangelets, into space. If a strangelet drifted through space and hit a star, it would convert the entire star into a lump of strange matter. If one hit Earth, it would eat the planet. Within hours, Earth would shrink into a hot, dense ball of strange sludge roughly the size of a soccer stadium. This scenario is the grey goo of astrophysics, and while it is unlikely, we cannot prove that the universe isn't full of these invisible, infectious mines waiting to be stepped on. We have talked about the possibility that the universe is a cycle, a big bang followed by a big crunch, repeating forever. For years, this was just a nice idea, but one Nobel Prize-winning physicist, Roger Penrose, claims he's found the scars of the previous universe. Penrose calls his theory conformal cyclic cosmology. He argues that when the universe ends in a big freeze, it eventually forgets how big it is. In a universe with no matter, only light, size and time lose their meaning. The infinite cold future becomes mathematically identical to the infinite hot big bang of the next cycle. But black holes from the previous universe would leave a mark. Before they evaporated, they would release massive amounts of energy. This energy would leave circular ripples in the next big bang like raindrops on a pond. Penrose calls these Hawking points, and when he looked at the map of the cosmic microwave background, he found them. He found spots of inexplicably high energy surrounded by rings, exactly where his theory predicted dead black holes from the last aeon should be. Other scientists are skeptical, claiming the spots are just statistical noise. But if Penrose is right, we are looking at the ghosts of a dead universe. We are seeing the tombstones of galaxies that died trillions of years before our sun was born. And it means that one day, our own black holes will leave ghost circles for the next universe to find, a final message saying, "We were here."